This is a black hole. These cosmic oddities might seem like something out of science fiction, but they're very real. But how do they form, and what will happen if you fall into one? Stars are giant balls of gas, mostly hydrogen. They are born from collapsing gas clouds under their own gravity. At their core, a superhot process called nuclear fusion takes place. It's like a cosmic tug of war. Fusion creates tremendous energy that pushes outwards, while gravity tries to pull everything in. As long as this balance holds, the star shines brightly and stably. But for stars much heftier than our sun, the story gets even more interesting. The intense heat and pressure in their core allow them to fuse heavier and heavier elements, all the way up to iron. And that, as they say, is where things get tricky. Unlike the other elements forged in the star's fiery heart, iron is the ultimate party pooper. Fusion of iron doesn't release any energy. It just piles up in the core. This growing iron mountain disrupts the delicate balance between the outward push of radiation and the inward pull of gravity. But suddenly, the party gets over. The core can't hold itself up anymore and bam, it collapses in a fraction of a second. This triggers a chain reaction, causing the entire star to implode. The remaining layers of the star rush inwards at a quarter the speed of light, feeding even more fuel to the collapsing core. It's during this dramatic implosion that the magic happens. The intense pressure and heat forge all the heavier elements in the universe, from gold to platinum. In a way, the star throws one last epic party as it explodes in a dazzling supernova, scattering these newly created elements across the cosmos. Think it is going out with a bang and a sprinkle of gold dust. This produces either a neutron star or a black hole. The fate of the collapsed core depends on its weight. If it's not quite massive enough, the leftover material gets squeezed into an ultra-dense ball called a neutron star. But for true heavyweights, things get even more extreme. If you looked at a black hole, what you'd really see would be a point of no return around the collapsed core, called the event horizon. This isn't a physical surface, but a boundary. If you dared to cross it, you'd need to be moving faster than light itself, which is not possible astronomically. So anything that gets too close is doomed to fall in. We can't see the collapsed core directly because it's shrouded by the event horizon, appearing as a black sphere that reflects no light. But the whole part, that's where things get weird. It's called a singularity, and honestly, we have no idea what it's really like. Think to divide something by zero. That's kind of what a singularity is to our current understanding of physics. It might be a point of infinite density, where all the star's mass is crammed into a single spot with no size or volume. Or it could be something entirely different beyond our current scientific grasp. The truth is, we just don't know yet, which makes black holes even more fascinating. Black holes aren't like vacuum cleaners, as you see in the movies. Forget the image of a black hole as a giant space vacuum cleaner, sucking everything in. If we magically swapped our sun for a black hole of the same mass, Earth wouldn't get sucked in. The main difference, we'd all freeze solid because the black hole wouldn't release light and heat like our sun. But what if you actually fell into a black hole? Time gets weird around these cosmic giants. From an outside observer's perspective, as you approach the event horizon, the point of no return, you'd appear to slow down. Think it as time itself hitting the brakes. Eventually, you'd seem to freeze in time altogether, like a cosmic pause button. You'd also stretch out and redden due to a mind-bending effect called SPAGHETTIFICATION. But from your own perspective, things would be wildly different. You'd see the rest of the universe speed up dramatically, like a cosmic fast-forward button. In a way, it would be like watching the future unfold before your eyes. However, this wouldn't be a pleasant experience, as the tidal forces would tear you apart long before you reach the singularity, the mysterious point at the center. Black holes are truly bizarre objects, and what happens beyond the event horizon is still a mystery. This is what makes them so interesting. What happens after you cross the event horizon? Buckle up, because things get dark, literally. Here are two possible scenarios. For the first one, Think a black hole curving space-time so intensely, it becomes a one-way street. Crossing the event horizon is like entering a super tight alleyway that gets narrower with each step. There's no turning back. The black hole's immense gravity creates a tidal force, like an invisible hand stretching you violently. This isn't your average morning yoga session. In a split second, the force could be millions of times stronger on your feet compared to your head. The result, your body gets ripped apart at the cellular level, turning you into a thin stream of superheated gas, essentially a human-flavored spaghetti. Yikes. This spaghettification is the leading theory, but it's important to remember that what happens beyond the event horizon remains a mystery. There could be other forces or phenomena at play that we don't yet understand. That's the captivating thing about black holes. They push the boundaries of our scientific knowledge. 2. You die a very quick death. Very soon after you cross the event horizon, you would hit a firewall and be terminated in an instant. Neither option is particularly pleasant. How soon you would die depends on the mass of the black hole. A smaller black hole would kill you before you even enter its event horizon, while you might survive for a while inside a supermassive black hole. As a rule of thumb, the further away from the singularity you are, the longer you last. Black holes come in different sizes. There are stellar mass black holes, a few times the sun's mass, and roughly the size of an asteroid. On the other end of the spectrum, we have supermassive black holes, found at the heart of galaxies and feeding for billions of years. The biggest one known, S50014 plus 81, is a monster, 40 billion times the mass of our Sun and 236.7 billion kilometers in diameter. That's 47 times the distance from the Sun to Pluto. Black holes are powerful, but not invincible. Over vast timescales, they evaporate through a process called Hawking radiation. Imagine empty space isn't truly empty, but filled with fleeting particle pairs constantly popping in and out of existence. Near a black hole, one particle from a pair might get sucked in while its partner escapes, becoming real and carrying away energy. This is the black hole losing energy. It's an incredibly slow process at first, accelerating as the black hole shrinks. Imagine a black hole shrinking to the size of a large asteroid. It'd radiate at a lukewarm temperature, further shrinking to a mountain-sized mass. It'd radiate with the heat of our Sun. In its final moments, a black hole releases a colossal burst of energy, like billions of nuclear bombs detonating at once. However, this is an incredibly slow goodbye. The largest black holes might take a Google year, that's a 1 followed by 100 zeros, to evaporate entirely. Long before the last black hole fades, the universe will be a cold and lonely place, with no witnesses to this slow-motion spectacle. But what will happen when our Sun flips in mid-2024? This video is up next.